Hi, my name is Tajana Rushoff, and I will be introducing a 30-year analysis of shoreline change along the Florida coast using geospatial modeling. Florida's coastline is constantly evolving, and over the past 30 years, changes in sea level and a changing wave climate have accelerated shoreline erosion along the East Florida coast. This study uses satellite remote sensing and elevation analysis to further understand shoreline change in St. Augustine, Florida, focusing on Conch Island between the years of 1995 and 2025. Now, the question we're asking today is, how has the northeast Florida shoreline changed over 30 years, and what could be the possible contributing factors? Now, we'll discuss a brief history to help better understand what's going on with this study. Now, Florida sits on the Florida platform, and this platform is a carbonate structure. During the Jurassic, over thousands of years, massive amounts of carbonate deposition created the structure that the Florida Peninsula sits on today. Now, on the coast, the carbonate platform creates a continental shelf, or a slope off of the coast. On the west coast, the slope of the continental shelf is gradual, whereas on the east coast, the continental shelf is steep. Now, this research aims to review the highest erosion rates around Conch Island and compare the slope of the shoreline to see if there's a connection between the steep continental shelf on the east coast and erosion rates on the shoreline at Conch Island, Florida. In this study, I used Landsat 5, 7, 8, and 9 to create a shoreline change from 1995 to 2025. I also derived MNDWI values to delineate water and the land boundary to calculate that shoreline. This study also uses Landsat as well as Centennial 2 to calculate and show erosion rates along the coast. Additionally, LiDAR-derived DDMs are used to calculate the slope off of the coast and compare it to the erosion rates around the study area. MNDWI isolates the water and land boundary by comparing green and shortwave infrared reflectance. The workflow of this study began with Google Earth Engine and pulling Landsat images to analyze shoreline change from 1995 to 2025. In Google Earth Engine, I also pulled Landsat and Centennial 2 to extract erosion data. I then followed by going into ArcGIS Pro and pulling the information from the LatSat images and converting it into a GeoTIFF to reclassify the information and delineating between water and land. I then took that raster data and converted it to a polygon and then polygon to line to get the shoreline edges. With the erosion rate I pulled from the Landsat and Centennial 2, I converted it into a raster data set. And then I pulled a LiDAR DDM from 2024 to ArcGIS Pro for a slope analysis. To first begin this research, we must ask, is there even erosion happening? Is there even a shoreline change? We can begin with 1995 with our basic shoreline. And in 2000, with the blue dotted line, we can see that it's changing, but is it really decreasing? And in 2003, we can see that it decreases a bit from 2000 with the gray dotted line. By 2013, we can see that it recedes a bit more, and same with 2016 and the neon green line. 2019, that trend continues, and by 2022, it stays a little bit more stable, but we can say that there is a shoreline change happening from 1995 to 2022. Now, this next step is completed in Google Earth Engine, and we're asking the question, where is erosion occurring if there is a shoreline change? In 1995, we can see our basic or original shoreline. In 2025, we can see that it has, in fact, decreased, but also changed in a few areas. Now, on the image on the far left, we are seeing erosion and accretion, so we're seeing where land is being added and where land is being lost. The red is demonstrating the erosion, and the dark blue is demonstrating accretion. These two images are of Conch Island, and it's showing a side-by-side of Google Earth Engine and ArcGIS Pro in a raster dataset of where erosion is occurring at its greatest amounts along the coast. Now, coming into our research question, does slope have an effect on erosion rates? We know that slope of the coastline has an effect on wave climate and sea level rises and its effects on the coast. And so therefore, we would infer that that's going to have an effect on erosion rates. Now we can see on the image on the left that we're having high sloping on the coast. We can see the orange, we can see the red, and we can see the steep drop off straight off of the coast. And in its correlating position to its erosion rates, we can see that there's a lot of erosion happening in that area. We can also see this with an area where less erosion is occurring. As we can see in the image on the right, there's some erosion happening, but not as much. Now, this is still all in Conch Island, just a little bit down the coast. Now, we can also see in the slope analysis, there is still sloping occurring, but not as great as the previous image. We can tie a connection between erosion rates and sloping as we look along the coast, and especially at the areas around Conch Island. In our key findings and our previous images showing erosion rates, we see that shoreline erosion is not uniform. Yet there are specific hotspots around Conch Island that show accelerated landward retreat. We can also see that there is a direct correlation between steep sloping off the coast and rates of shoreline erosion. Steep sloping amplifies vulnerability to waves and sea level rises, which does in turn create erosion of a shoreline. This study demonstrates a measurable shoreline change along the northeast Florida coast, specifically at Conch Island in St. Augustine, Florida. We can see this over a 30-year period using satellite-derived MNDWI analysis, as well as erosion hotspots correlating with steep sloping coastal zones that is consistent with a Florida platform geomorphology and its known vulnerability to sea level rise and wave climate action. Now, thank you for listening and have a great day.